basic matrix operations today. Tomorrow we're going to do matrix multiplication. Wednesday and Thursday we're going to do Cramer's rule. There is a formative this week, Friday, leading up to a test next week, Thursday. Okay, so test next week, Thursday on the 15th. Okay. With a formative this week. Okay. Great. Yours?
It was fun.
Good. Good.
I ran around with some kids.
Nice.
No, yeah, it was fantastic. That's fine.
So, matrices. Okay. Matrix is the singular. Matrices is the plural. Okay. Okay. A matrix is a rectangular arrangement of numbers organized into rows and columns. Okay. Okay. Matrices, or a single matrix, if you will, are named using capital letters. So if I say matrix A, you would use a capital A for that matrix. And the individual numbers that you have, or the individual letters, or all the spots, if you will, in your rectangular arrangement, all of those are called elements. So a 2x2 matrix has 4 elements. A 9x2 matrix has 18 elements. Okay. Matrices have 2 parts to them. They have rows and they have columns. The one thing that you need to memorize is that whenever you are dealing with matrices, it is always rows by columns. Everything that you do, with the exception of 2 things with matrices, is always rows by columns. We classify a matrix using its dimensions. And the dimensions is, in this particular case, the dimensions of matrix A. Matrix A has 2 rows and 3 columns. So matrix A is a 2x3 matrix. A 2x3 matrix has 6 individual elements. Okay? In row 1, column 1, the element is 3. In row 1, column 3, the element is 4. In row 2, column 2, the element is 0. Those are also called addresses. Okay? So the address of element 3 is A11 because element 3 shows up in the first row, first column. element of -5 shows up in the second row, third column, so its address is A23. Addresses are different than dimensions. This week we are going to be doing operations involving matrices. The first two operations that we are going to be dealing with is addition and subtraction. Okay. In order to add or subtract matrices, you must have equal dimensions. It's the first check that you're always going to do with matrices. No matter what, you need to at least, very minimally, in your brain, say that the first matrix is what's its dimensions? Rows by columns. There are 2 rows and 2 columns. So this first matrix is a 2 by 2 matrix. The second matrix is it's also a 2 by 2. It's got 2 rows and 2 columns. Okay. Every matrix problem, you need to at least make a mental note of the fact of what dimensions you've got going on. Because with different operations come different rules that need to apply. In addition and subtraction, those dimensions have to be the same. Are those dimensions the same? Yes. So now I can add those matrices. And to add or subtract matrices of equal dimensions, we simply add the corresponding elements. So here is row 1, column 1. Here is row 1, column 1. So in my resultant matrix, I am going to have 4 plus 2 in row 1, column 1. In row 1, column 2, I've got a 0 and a 7. So I add those two together. In row 2, column 1, I have -6 and -1. And in row 2, column 2, I have 2 and -5. Okay? So my resulting matrix is a 2 by 2 matrix because it's going to end up being the same size. Now, when I read off a matrix, I read it like I read a book. Left to right, top to bottom. Okay? And after each row, you pause. Okay? So you're listing off, so I'm going to list off 4 numbers. So I would list them off as 6, 7, -7, -3. Left to right, top to bottom, pause after each row. Okay? Also helps to tell the person that you're communicating with what the dimensions are first. So if I were to say this to you right now, I would say it's a 2 by 2 matrix, 6, 7, negative 7, negative 3. Okay? So that you know, okay, I got 2 rows, 2 columns. I got so the first 2 numbers pause, reset, and so on and so forth. Okay? You try that one. I get, in the end, the 2 by 2 matrix of 6, negative 5, 12, negative 8. Yes?
Yes.
Questions on that one? 3 minus negative 3 is like 3 plus 3, which is 6. Negative 5 minus 0 is negative 5. 10 minus negative 2 is like 10 plus 2, which is 12. Negative 4 minus 4 is negative 8. Yes? Okay. One of the, I don't want to say classic type of problems, is this. Okay? Find me values of x and y that make that a true statement. Okay? So again, the first thing that you need to do is you need to determine dimensions. Dimensions of the first one, 2 by 2. Dimensions of the second one, same, 2 by 2. Dimensions of the resultant matrix, 2 by 2. Okay, so that all matches up. Just out of curiosity, what would happen if one of those dimensions wasn't the same? So then what's my answer? Not no solution. What do you got? No? Is it even possible to add a 2 by 2 matrix and a 2 by 3 matrix, let's say?
Yes.
Is it possible?
It's not possible.
It's not possible, so my answer is
Not possible.
not possible. Okay? Because you can't even get to the fact that there might be a solution, but they all cancel out kind of a deal. That's what we reserve no solution for. If the dimensions aren't the same, it's not possible. Okay? Okay? So, mental note for these dimensions, we said that they were all the same. That's good. That means it's possible. That means we can find something. Okay? So, I'm looking at the fact that x is down here in this second row, first column. Here is my other second row, first column. Here is my other second row, first column. So x plus 7 has to equal negative 2. What is x? Negative 9. Okay? So x here is negative 9. Y is located up here in the first row, second column. Here are the other two first row, second column elements. So 1 plus 6 has to equal y. So therefore y is 7. So when x is negative 9 and y is 7, that is a true statement. Yeah? The next operation that we are going to learn is something called scalar multiplication. Scalar multiplication is when you take a matrix of any size. This will work on any sized matrix. Okay? And you multiply that by a real number. Okay? It's very much like, or very much akin to, distributing. Okay? Because you're going to take this -3, that's my real number that I'm multiplying by, and you're going to multiply every single element by -3. So -3 times +3, and -3 times -2, and -3 times +1, and -3 times -10 is going to give me a 2 by 2 matrix of -9, +6, -3, +30. Another awesome style of problem that you will see is a combination of those three things: scalar multiplication, addition, and subtraction. Please try this one now. So this is going to be the 2 by 2 matrix of 8, 12, -4, and 20. And we are going to add that, or excuse me, subtract from that the 2 by 2 matrix 6, -4, 1, and 5. 8 minus 6 is 2. 12 minus -4 is 16. -4 minus 1 is -5. 20 minus 5 is 15. So our resultant matrix is a 2 by 2 matrix, 2, 16, -5. Questions so far? Calculate the resultant matrix. That's a little. So, is it possible?
Yeah.
Yes, because they're both 2 by 2s, right? Okay. Even after the scalar multiplication, they'll still be 2 by 2s. 1/4 times 8 is 2. 1/4 times -12 is -3. 1/4 times 0 is 0. 1/4 times 4 is 1. Two times -3 is -6. 2 times 7 is 14. 2 times 1 is 1. 2 times -2 is -4. 2 plus -6 is -4. -3 plus 14 is 11. 0 plus 2 is 2. 1 plus -4 is -3. So my resultant matrix is the 2 by 2 matrix, -4, 11 to -3. Okay? Oh, I hit it. There it goes. Yep. So find me the necessary values of x and y that make this matrix equation true. Ready?
Yes, now I'm ready.
What do we get for x?
2.
2, 0, 6. What you got, MSA? That a girl?
That's what I
Okay. What do we get for y? 12? 12? Alright, well let's check it out here now. So, x is in first row, first column, right? So that means I've got to take my first row, first column, and my first row, first column. Because there's scalar multiplication going on. So that's going to be 3/4 times -4 plus 3. Ooh, it's really acting funky today. Is going to equal x. That's supposed to be a 4 in the funkiness. Actually, I should keep it down there. So 3/4 times -4 is -3. -3 plus 3 is going to be x. So x is 0. Okay? Did you forget the negative sign? I know. Okay? So here
I was like, oh, 3.
is the first part, 3/4 y, plus -4, so just -4, equals 5. Okay? Add 4 to both sides. That gives me 3/4 y equals 9. I could multiply by 4, divide by 3, or I could just straight up multiply by 4/3. Either way, y here, oops, I used wrong color. Either way, y is equal to 12. Reciprocals. Okay? Good to go on that one. I know. What a nice guy your math teacher is. When's this one going to be due tomorrow, though?
Not tomorrow.
Give you another chance. You more than likely will finish it in class yet today.
So I guess tomorrow by the end of the day.
So tomorrow at the beginning of class?
At the end of the day.
All right, let's go tomorrow at, if you're in the first class, we'll go tomorrow at 12:02.
All right, deal.
Okay? And if you're in the second class, we'll go tomorrow at 1:02.
Seems legit.
Okay.
No, 101 for them because they